Welcome to our next video for Stat 212. So in this video, we're going to talk about statistical power, and we're going to compare that with internal validity because those are two related things, or I should maybe say that they're easy to confuse. And we just want to kind of carefully distinguish those two things and how they matter with design, and then end with some additional considerations about kind of judging the strength of a study. All right, so I'm sure that many of you probably haven't heard this term before. Maybe some of you have, but I'm going to guess this is probably a pretty new idea for a lot of folks. But statistical power has to do with how well our data, how well our design is set up to confidently detect an association or effect that can't be explained by random chance. And so one thing that I like to point out here is that statistical power doesn't relate to causality. So, in other words, statistical power just has to do with my ability to find something. That could just be a mere association. It could be causation, but the underlying idea here is that I'm just, it has to do with my ability to find something going on here. And so there's some different things that are going to be related to statistical power. So some different considerations that I might make in my design that, may improve or, damage my statistical power. So we're going to talk through those. But the most common way to improve statistical power is to just increase your sample size. So as an example, let's say, I don't know why I'd be doing this, but let's just say that I'm comparing two coins. And I want to know if they are equally fair. Like when I toss them and record if they're heads or tails, I'm curious if they are both equally likely to come up heads and tails, or if there might be a difference between these two coins. Let's say that I flip each of them about 15 times, and one of these coins I get 9 heads and 6 tails. One of these coins I get, say, 8 heads and 7 tails, or 8 tails and 7 heads, whatever. Well, yeah, that is clearly some difference, but the truth is that if these coins were both equally fair, that's still a result that I would expect to come up. Like, that's not a surprising result. And that's because if I don't have a very large sample size, it's going to be kind of hard to detect a difference unless the difference is really big, right? Unless it's like 80-20, 20-80 or something like that, in which case, yeah, maybe I don't need a lot of sample size to notice that. But if the difference between these coins is a little bit more subtle, then I'm going to need a lot more data before I can confidently detect that. So, maybe I need to flip these coins a couple hundred times, maybe even 1,000 times before I get kind of a discrepancy in the proportions that really can't be explained by random chance anymore. Like these are just too discrepant to happen by random chance if the coins were fair. So statistical power has to do with my ability to find a difference or an effect or an association or whatever, from this data. So sample size obviously is going to relate to that. The higher my sample size, the stronger my statistical power is going to be. But there's also some other things that can improve our statistical power as well. And one of them is a within group design as opposed to between group design. And that has to do with kind of decreasing random noise in our measurements. And so what I mean by that is, let's say that I'm studying the durability of two different shoe materials. And so what I do is I find some people to wear shoe A, and I find some people to wear shoe B, and then I look at how much wear and tear has been taken on each of those shoe types over time. So I just have my kind of clump of measurements from one group, my clump of measurements from the other group, and I'm trying to find kind of an average difference. But there's a lot of variability from person to person and how much they wear their shoe, how they wear their shoe, that maybe that's kind of hard. Like it might be kind of hard to detect a difference because there's just so much variability in each of these sets of data that I would need a lot of data before I can see that. Well, there's something else that I could do to improve my statistical power, and that's to do with in-group design, where I have one person wearing each shoe, like each person's wearing an A shoe and a B shoe on different feet. So then I can directly compare the difference in wear between those two shoes, and I can do that for a number of people, and it's going to be a lot easier to detect if there's a durability difference because I have a much more controlled comparison, right? I just have one person's two shoe comparison as opposed to kind of this group versus this group. So when we get to two sample testing, we'll talk about that difference in efficiency, that an independent samples t-test is not as efficient, it's not as powerful as a paired t-test. So if I have, the ability to do paired measurements, like a match pairs design or a pre-post design or something like that, that can improve my statistical power in that case. I also like to mention this, not because it has a big effect, but it has a very small effect, and it often mistakenly gets thought of as relating to internal validity, but it does not relate to internal validity, and that is having relatively equal group sizes. That if my group sizes are relatively equal, I get more statistical power than if I have really uneven group sizes. And that just, again, it relates to sample size, right? So if I only have 20 people in one group and 80 people in the other, well, I'm getting more, let's just say I'm getting more bang for my buck to even them out, and have more people here, to make sure this is higher as opposed to just pushing this one higher and higher. So having about 50 and 50 or 45, 55 or something like that is going to be a lot better than having something like 80, 20. That said, it doesn't matter that much. And you don't be super concerned about equal group sizes like this is just the be all end all. Like if we're off by 1 or 2 or 3, like this is a big deal, because it's not. It really is not at all. But if I have really noticeable discrepancies, then I am going to start to hurt my statistical power a little bit. And the more uneven it gets, the more I'm kind of lowering that. So keeping your group sizes closer rather than farther is better if you can and it makes sense to do so. Okay, so with these ideas in mind, let's directly compare these two things. So here we have two different study designs to answer kind of the same type of question, or the same question but two different options. And let's talk about which design has better internal validity and which design has better statistical power and why. So the first option, that we'll call this study 1, we have 100 people complete a pre-post design where everyone takes a memory recall test, exercises for 15 minutes, then takes the same memory recall test. In the second design, we have people randomly assigned. So 50 of these 100 people are randomly assigned to sit for 15 minutes and then take the test. The other 50 are assigned to exercise for 15 minutes and then take the test. So go ahead and think on your own first. Which design do you think has better internal validity? Which design do you think has more statistical power? But I will go ahead and answer. So I would definitely say that study 2 seems to have the better internal validity. And it's kind of easier to explain that by noticing what's wrong with study 1 in terms of internal validity. Study 1 doesn't have a control group, which means that study 2, I guess I'll just say this in the positive, it has a control group. And if you don't have a control group, there's several things that creep in. Is there a placebo effect, right? Are people just, doing better the second time because they're, because of reactants and because of, placebo effect and things like that? Because if there's no control group, I have no way of kind of canceling out those things and seeing, what's going on in the control group and comparing apples to apples. So all those things are kind of on the table when I don't have a comparison group. The other thing that I would definitely mention here is a test familiarity threat. So I guess actually what I should say here is no test familiarity threat. Right, so in study 1, people are taking a memory recall test, then exercising, and then taking the test again. I mean, I don't know about you, but people might just be getting better the second time because it's a memory recall test, or depending on what's being done here. So I guess I should probably clarify here. If what's meant by a memory recall test is they tell them some words and then they exercise and then they do it again, well, I guess that's just a complete assessment at that point. But if we look at what's going on in the treatment group, the memory recall test is all happening at once. So it sounds like it's like like one session is a complete memory recall examination. So the fact that I have people doing that complete process twice in study 1 is a problem, because they might just be getting better at it the second time, and that has nothing to do with whether they exercised or not. So definitely that could be a concern for study 1 that we don't have in study 2. But if I'm judging this for statistical power, I have to be honest and say that study 1 has more statistical power. For one, this might be strange, study 1 technically has a larger sample size. And what I mean, well, I guess I should clarify, it's not really a larger sample size, but it's more measurements. So more measurements. And that's because I'm having everybody do the treatment intervention. Everybody is doing the exercise and contributing results. So now what I have is 100 pre-results and 100 post-results. Whereas in study 2, I only have 50 of each. So 100 versus V100, not 50 V50. But, at the same time, that does improve my statistical power. I have twice as many measurements in study 1. The other thing is that study 1 is a within group design, which means it's going to be more efficient. I'm getting measurements from the same person twice for comparison, as opposed to making comparisons of independent groups. So within group design is going to improve my power because it's a more efficient comparison that parses out some of that random noise. Okay, now that said, right, you might be looking at this list and saying, oh, well, study 2 has 2 bullet points going for it, study 1 has 2 bullet points going for it, so I guess they're both equally good in different ways. I would argue no, and this is a really important point. Internal validity is almost always more important than statistical power, and if you're making design choices, you should almost always go with improving validity as opposed to improving power. And I would explain it like this. Validity has to do with how trustworthy your design is. It's quality. So think of this as quality. Think of this as quantity. And you should almost always choose quality over quantity when you're making design decisions, because you can't go back and fix a bad design after it's done, but you could always get, well, not always, but you could often get more participants or a larger sample if you need to on the right. Or it's just better, like I would also just say it's better to have a small study done well and to trust your comparison than to do a large study where you have a lot of questions about the comparison and there's a lot of uncertainty about if you can trust it. So just as in life, quality over quantity most of the time. So it's a big greater than sign. Quality is better, greater than quantity. Now, I'm not going to say that you should never care about statistical power, that if you're making design decisions, it is always this way. I suppose if your sample size is just so small that you know, like let's say that you had like 15, like 20, 25 people and you're dividing them between two groups, that's a little iffy, right? Like you probably don't have enough statistical power to do anything with that. Even if it's a well-designed experiment, you just don't have enough people. It's kind of like me tossing coins 15 times each, like that it may not be enough. So that might be a case where you choose a pre-post design or something like that that gives you more statistical power, because otherwise you just don't have anything, right? So quality doesn't matter if you have no quantity at all or very little quantity. So that might be a case where you make that flip decision. But for the most part, pick validity over power most of the time. Okay, so just some additional thoughts here. So do validity threats signal mistakes or biases from the researchers? Well, I would say it might be tempting to think that all experiments with validity threats are simply due to poor planning, research bias, whatever, but that's usually not the reason. So in many experimental settings, it's just there's unavoidable validity threats, like you just can't get around them. So don't assume a validity threat is a mistake or a bias as much as it's just an inherent existence of of what happens in research. Now, obviously, some studies are better than others, right? It's like there are some poorly planned studies, but there are some really, really good studies that have validity threats because they just can't get around them. Like this is literally the best that they can do. The other thing that I would say, just kind of going back to like, well, we just talked about quality over quantity. Why do people ever do a pre-post study? Or why do people do, a non-randomized controlled experiment or things like that, or an observational study? And again, it's kind of the same answer. Like, it might just be that I can't not do it, like that I can't do something better given the nature of what I'm studying. And like, also keep in mind that getting pre-post measurements, like, what if the validity threats, like what if the placebo effect or the test familiarity threat is like very, very minimal? Well, maybe it's worth it in that case. So it's always kind of a balanced question of, like, what am I losing by gaining this? Like, sometimes there's kind of that tension that you have to weigh. So just kind of, keep your eyes open about these different considerations, use different biases that can kind of follow your studies, and making wise choices that, generally favor strong internal validity and, try to have some okay statistical power along the way. And then one last consideration here is, I need to get my head out of the way there. So good science isn't just finding one perfect study and reporting the result. Good science is taking a bunch of okay studies and seeing what the consensus is. So it's not about finding just the perfect study or the best study. It's about like, well, what do the studies seem to be saying, and like let's find the good studies and weight them a little bit more than the not so good ones. But in general, what is the consensus of studies saying? That's really more of what science and research would be about.